We will dedicate this lesson to Gigi. Somebody want to give a shout out to Gigi? Nobody wants to give you a shout out, Gigi. Sorry. Nobody even cares. Here we go. It doesn't matter. I got triangle A, B, and C. Okay. And the issue is we want to talk more about this whole solving triangle piece, but we have some challenges in front of us. And the first challenge is really that so far we've always needed an angle on its opposite side. But what if we have a triangle that has, say, all three sides are given to us in 0 angles? Can we solve it? Well, hold on. Just to be clear, you guys learned in geometry that side, side, side is a congruence theorem, correct? So if we're given all three sides, we should be able to solve it. So we got to say something intelligent. This is A. This is B. Good. Way to say something intelligent. Let's say something more because there's a height. Very good. You guys have caught on to our magic. This is H. And so far what we've done in these situations is we've said the sine of an angle, okay? And we focused on sine of C was like, say, H over B. But, and we involved C into that situation as well. The problem is that we want to say something intelligent about all three sides. All three sides. Is that a length of A? We'll call it X. So what's this length right there? A minus X. So how about this? X squared plus H squared is equal to B squared. You okay with that? Pythagorean theorem. How about this? A minus X squared plus H squared is equal to C squared. You okay with that? So we've said something intelligent about the three sides, but the problem is in most triangles we wouldn't be given H and we wouldn't be given X, would we? See a way we could get rid of the H's? Hey, if they're both equal to H squared, then they're both cool. We said get rid of H's. We delivered. If they're both equal to H squared, so do you agree that this is H squared? Good job. Good. Yep. Excellent. Got it? Okay. Pythagorean theorem. Okay. Would be nice to get rid of the x's, wouldn't it? Let's see here. How about I FOIL that out? Minus a squared, good. Plus 2ax minus x squared. Hey, what do I notice? What cancels? Why? B squared equals C squared minus A squared plus 2ax. Our goal is to get rid of the h's. Our goal is to get rid of the x's. We got rid of the x squareds. But we've got a stinking x left over, don't we? Like, it was, we tried, didn't we? It was a good run. It was a good run. Good work. It's over. Give up, right? If only we could say something intelligent about x. If only we could say something intelligent about x. If only we could say something intelligent about x. Can I solve for x? What can I do with that? Looks kind of messy, doesn't it? We're going to clean it up just a hair. This is the law of cosines now, but we're going to make it look a little prettier. We're going to subtract c squared from both sides. And we're going to subtract b squared from both sides. And when I do that, I get a negative c squared equals negative b squared minus a squared plus 2ab times the cosine of angle C. And furthermore, I'm going to get rid of the negative by multiplying through by negative 1. I get c squared equals b squared. Whoop. We'll go a squared plus b squared minus 2ab cosine of angle C. What's that? Now look what I've got, okay? This is really important. And this will help you kind of connect with it. Look at how it starts out. C squared is a squared plus b squared. What is that? That's just Pythagorean theorem, isn't it? And then you subtract this weird thing off. Now, let me show you what that means. Okay? This is cool. 90-degree angle, right? Okay? Would you agree on that triangle? A squared plus b squared is c squared? Well, what is the cosine of 90 degrees? Okay, what's the terminal point up at 90? 0, 1. Okay, is cosine the x value or the y value? X value. What's the cosine of 90? 0. Okay, so look what happens. When you use 90 degrees, what happens to this thing right here? It's gone, and you're left with c squared is a squared plus b squared. Pretty cool, huh? Okay, try this. Okay, watch this. I'm going to make an angle that's smaller than 90 degrees. Pythagorean theorem really doesn't work anymore, does it? So watch what happens. If you want to find this opposite side C, did it just become shorter or longer? It became shorter. Okay. Angle greater than 90 degrees or smaller than 90 degrees? Smaller. So is it in the first quadrant or second quadrant? First quadrant. Cosine in the first quadrant, positive or negative? Positive. So you'll do a squared plus b squared, and then you'll subtract off a positive thing, and you'll come out with a smaller amount. What if I make the angle slightly larger? Okay? Tell me this. If the angle is slightly larger, okay? Bigger than 90 or smaller than 90? First quadrant, second quadrant. Is cosine positive or negative in the second quadrant? Negative. So when you do this, you subtract off a negative, which is adding, and you become a larger length. So this is just the Pythagorean theorem modified. That's all it is. So you need to know this. Be able to look at your notes and find all three. Okay. So as you look at the notes, you can see c squared is a squared plus b squared minus 2ab cosine of c. What is nice about this, okay, it's written three different ways. What's important is that look at the side. If I'm finding side C, then I require angle C. If I'm finding side B, I require angle B. And you look, there's a nice pattern that rings to it. Okay, we'll write it out on our sheet here. If you flip it over to this part, it says law of cosines. The one that we wrote was c squared is equal to a squared plus b squared minus 2, you keep these two the same, so AB, and it's cosine of the angle of the side that you're finding, so cosine C. So let's just try to switch it and see if you can come up with the right order. So what if I have B squared? Then what follows? Good. AC, cosine of B. How about A squared equals minus 2 BC times. Very good. And the law of cosines is super awesome and powerful, and we love it. We can use it to solve for triangles. Here's our triangle. A, B, C. A, B, C. A, B, C. Angle A is 26 degrees. Side B is 12. Side C is 15. What kind of triangle are you given? Side angle side. Why can't we just use the law of sines? You don't have an angle and its opposite side at all. If you don't have an angle on its opposite side, you can't use the law of sines. Our decision tree, if you look at it, it says when you're given with these situations, side angle side, use the law of cosines. There's one solution. So that's what we'll do. We'll set up the law of cosines. Which side do you think I start finding? I start finding A, because then I'll have an angle on its opposite side. So I'll use A squared is equal to B squared, or 12 squared, plus C squared, or 15 squared, minus 2 times 12 times 15 times a cosine of 26 degrees. Your calculator is incredible. It understands order of operations. Calculators I had when I was growing up did not understand order of operations, so you couldn't just do this. 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26. I press enter. Is that my answer? Square root 6.74. Okay, we know that C is 15. We know that B is 12. Piece of cake upside down. I mean, that really wasn't that bad, was it? No, not at all. Okay, now the question is what angle do we find next? And this is important. Okay, this is very important because this matters a lot. Okay, so you'd like to use the law of sines. So the question is, should we find angle B first or angle C first? And there is a right answer here. Okay, it's B. And here's why. Here's why. Okay, when we use the law of sines, okay, when we use the law of sines, suppose we came up with the sine of C is equal to 0.9. How do we know it's not obtuse? We don't. I'll show you. True or false? True or false? B must be an acute angle. True. Help you work through the reasoning. How many obtuse angles can a triangle have? One. Is everybody okay with that? So if this triangle does have an obtuse angle, which one would it be? It would have to be C. So let's avoid the obtuse angle option, and let's just solve for B. Does everybody agree that B has to be acute? Okay, so let's just solve for B. So sine of 26 divided by what? 6.74 is equal to sine of B divided by 12. Got my calculator. 12 sine of 26 divided by 6.74. And I get that. Inverse it. And we get 51.3 degrees. Subtract both of them from 180. $102.7. No. Here's the deal, folks. Yes. Because here's why. Suppose we would have gone for C, okay? You would have gone for C right away. Here's what you would have come up with. You would come up with sine of C is equal to 0.97555, okay? And you, on your calculator, would have gone sine inverse of the answer, and you would come up with 77.3. It's not 77.3, it's 102.7. This found the acute angle. You didn't know if it was going to be acute or obtuse. Do you have any question now, after we found these two, we know those two are correct. Is there any question on whether this is 102 or 77? No, our subtraction forced this to be 102, right? We know it's obtuse. But if you would have gone C first, you wouldn't know. And so that's why your decision tree says this. As you look at it, it says, one solution, use the law of cosines to solve for the missing side. When you use the law of sines then, to find one of the missing angles, start with the angle opposite the shorter of the two sides. So in our work, you can see we did exactly that. We wanted to start by finding not angle C, because that was 15. We did angle B because that was 12. Other? Go ahead. Well, you could solve for the obtuse, but the deal is that sine is positive. Sine is 0 here, 1 here, and 0 here. So if you get 0.9, then that means we're either referring to that angle or that angle. We don't know which one. There's no way of knowing. I don't know which one to pick. But if I solve for B first, then I can do my subtraction, and it turns out it's that one. We just didn't know that. We didn't know that. Good work. Last example. Triangle A, B, C. What kind of triangle we got here? Side, side, side. Did side, side, side work in your geometry congruence theorems? It sure did, and we can use it here. We're going to use the law of cosines. We just have to decide which one we start for. And this is where your last critical thinking piece comes in, okay? Law of sines. Where is sine positive? Which quadrants? 1 and 2. Cosine. Where is cosine positive? 1 and 4. Where is it negative? So here's the deal. Does cosine know the difference between first quadrant and second quadrant? It does. Does it know the difference between acute and obtuse? It does. If cosine comes out to be negative, it's an obtuse angle. If cosine comes out to be positive, it's an acute. Did I say that backwards? If cosine comes out to be negative, it's obtuse. If cosine comes out to be positive, it's acute. If there's an obtuse angle here, which one is it? C. Let's use the law of cosines to solve for angle C. 12.4 squared is equal to 9.1 squared plus 10.5 squared minus 2 times 9.1 times 10.5 times the cosine of C. As we go to solve this, this is the last most common mistake that people make on the test. They do this. 4 equals 10 plus 9 minus 7x. Okay, suppose I had that as my equation. If you had an 8th grader doing this type of equation, what would you say to them if they did this? Oh, we do 10 plus 9 is 19 minus 7 is 12. So we got 4 equals 12x. But people do it all the time here. People do it all the time here in trigonometry. This cosine of C is like an x. You've got all that stuff attached to it. You can't just take this plus this and minus that. You can't do it. So let's break it up into all the individual pieces it is and just solve for it. 12.4. Well, hey, what'd you do? You turned off? Turn back on. Come on. There you go. Yep, battery's dead. 12.4 squared. 153.76. 9.1 squared. 82.81. 10.5 squared. 110.25. Minus 2 times 9.1 times 10.5. 191.1 cosine of C. What do I do to solve? 153.76 minus 82.81 minus 110.25. I get negative 39.3 is equal to negative 191.1 cosine of C. So what do I do to solve? Divide by negative 191.1. So is cosine positive or negative? It's positive. So which quadrant am I going to be in? The first quadrant. So am I acute or obtuse? It's acute. So turns out that there are no obtuse angles in this triangle because this is the biggest angle we're solving for. 78.13. What can I now use to solve the rest of the triangle? The law of sines. Do I have to worry about coming up with an obtuse angle? Why? That's the biggest angle. Sine of 78.13 over 12.4 equals sine of A over 10.5. Do you understand now why I needed you to be quick at doing the law of sines? We're doing it a lot, aren't we? If you're not good at the law of sines, then this could be a total pain in the butt. 5596. And finally, 180 minus our answer minus 78.13, 4591. And that triangle to solve for. Yes. First of all, your decision tree for side, side, side says side, 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 one solution. Just start by solving for the angle opposite the largest side. So that's a fail-safe. If you want to understand why, again, what we say is this. Cosine knows the difference between positive and negative. It knows the difference between being in the first quadrant and the second quadrant. You need your worksheet, bud. Yes. I do. Just 1 second. Gigi, I gave your assignment to Jill Peterson. You can find it with her. Yes. We know that Jill is irresponsible and untrustworthy. Would you agree, Rianne? Eve? Whoa! I'm in trouble. I better leave. Goodbye. Goodbye.